The rings of Saturn are not merely transiently disappearing during an upcoming ring plane crossing in 2025, they are also in a continuous state of decline, shedding nearly 1 million metric tons of ring material each day. This massive loss of material, supported by a growing body of evidence gathered by Cassini and the Voyager missions, is reshaping our understanding of Saturn's iconic rings. Contrary to the long-held scientific view that the rings are a permanent fixture of Saturn, dating back 4.5 billion years to the planet's formation, the emerging narrative suggests a recent formation with a dynamic and changing ring system that is diminishing in mass with less substantial rings that are also darkening. Saturn may sadly be headed towards rings like those observed around Jupiter, Uranus and Neptune. And this is the story of how science is creating a new narrative for the rings around Saturn. 100 to 200 million years ago, Saturn had an additional moon, named Chrysalis, whose orbital stability around Saturn was disrupted by Titan, Saturn's largest moon. Titan is moving away from the planet, which destabilised the orbit of Chrysalis, setting it on a path perilously close to the planet. Eventually it crossed the Roche limit, a critical distance where tidal forces surpassed the moon's gravitational self-attraction, which led to its disintegration. With the body of Chrysalis pulverised, 99% of the disintegrated remains of the moon, water ice, was absorbed into the planet. However, 18 quintillion kilograms of shattered material was spared this fate and spread out along the original orbital path of the moon, and in doing so, Saturn's rings took shape. Today, orbiting the planet at 1800 kilometers per hour, the crushed fragments of Chrysalis still reside in the ring system. They are composed predominantly of water ice, with a 2% impurity from dust, rock and other materials. Most of these fragments are the size of snowflakes, while a few are the size of mountains, all contributing to an average ring depth of 10 meters. Saturn's rings shine brightly as sunlight is reflected back from the 98% water ice composition, giving us one of the brightest and most beautiful spectacles in the solar system. Yet the ring's pristine nature and brightness are under threat from pollution, a pollution which is helping science put an estimate to the age of the rings. In the emptiness of space, pollution may seem a strange concept, yet the interplanetary medium, the space between planets, is teeming with micrometeoroids, remnants from the formation of the solar system. Add to this mix the fragmented remains of collided asteroids and comets that ventured too close to the Sun, and it turns out the solar system is inherently a dirty place, where Earth and other planetary surfaces are constantly bombarded by micrometeoroids on a daily basis. Saturn's rings are no exception, and spanning across 280,000 kilometres, the rings present a surface area that is 100,000 to 1,000,000 times greater than a moon of similar mass, making them an easy target for the ceaseless bombardment of micrometeoroids. As a result, non-icy material is bombarding and polluting Saturn's rings at a rate of 1 gram per square foot per year, as discovered by the Cosmic Dust Analyzer aboard Cassini in its 13-year stay around Saturn. Over billions of years, this steady influx of cosmic debris would theoretically darken and reduce the brilliance of the rings, something we do not observe today, suggesting the rings are much younger than we have believed. Alternatively, Chrysalis was thought to be an icy moon, and when it disintegrated to form Saturn's rings, the water ice composition would have been nearer 100%. At the rate of bombardment observed, 100 million years would need to have passed before we see a 2% composition of non-icy material. And if it continues at this rate, the pollution will darken the rings, with the reflective nature of the water ice vastly diminished. But whilst influx of micrometeoroids into the ring system has polluted them over the last 100 million years, this high energy bombardment holds one of the secrets that's contributing to their demise, resulting in particles being poured into the planet at mind-blowing quantities. Saturn has a phenomenon known as ring rain, where material from the rings is being poured towards Saturn and raining down at a staggering rate of 10,000 kilograms per second. First discovered from data collected by Voyager 1 and 2, and later confirmed from the Cassini mission, ring rain has its genesis in the disintegrated remains of the ring material. Under the influences of UV light or the high-energy impact strikes of micrometeoroids, the ring particles become charged. These charged particles succumb to the planet's magnetic field, resulting in ring material being pulled along them, falling toward the planet as ring rain. At the staggering rate of 10,000 kilograms per second, simulations project a future where Saturn's magnificent rings may vanish within the next 100 million years, with some simulations proposing a mere 10 million years. While the evidence suggests Saturn's rings could be relatively young, undergoing rapid mass loss over the last 100 million years, the uncertainties surrounding their origin still persist. The enduring hypothesis that these rings are remnants from the primordial era prevails, hinting at the possibility of an unseen renewal mechanism, and rather than end up as dark ringed planets like Jupiter, Uranus and Neptune, Saturn may be destined to be forever the jewel of the solar system.